Nitin Chavan, he is Anurag Bhargav. We are from ENTC Department Division 3 of KK Institute of Engineering Education and Research. So our project topic is weather station. In this project, we use 3 sensors, and the data of these sensors is going to Arduino, and the data in Arduino is going to the Wi-Fi module, and the data in which Wi-Fi module goes to the IoT. Actually, we had seen what problems are faced by farmers about getting the proper information about weather report. Hence the problem statement: to design a cost-effective weather station for monitoring the environmental conditions in real time. Actually, this technology is already existing, but it is very costly. It is up to 18,000 to 50,000, and we designed this project in under 2,000 rupees.
As my friend Darshan explained, we are considering different sensors with different parameters. So we are considering 4 parameters: temperature, humidity, air quality, and light intensity. For sensing temperature and humidity, we are using DST11 sensor. It has 3 pins, 2 for power supply, VCC and ground, and 1 is data pin, from which we are giving the data to the Arduino. Then we are having MQ135 sensor, which is used for air quality. It has 4 pins, 2 for power supply, VCC and ground, and 1 is analog output and 1 is digital output. Here we are considering analog output. Then there is LDR, which is used for light sensing. Then this all the data from sensor we are giving to Arduino, and from Arduino we are giving it to Wi-Fi module, and this data is then stored to the ThinkSpeak. Then this is the block diagram. DST11, MQ135 and LDR sensor are giving input to the Arduino, and from Arduino we are giving output to the LCD, and then ESP8266 module get the data, and we are collecting it to ThinkSpeak IoT Cloud.
Hello friends, myself Nitin Chavan. As explained by my friends Darshan and Anurag, I will continue further. So we are from ENTC department of the institute, KK Engineering Institute of Engineering Education and Research. So we are going to see our project named Weather Station. So my group members are Anurag Bhalrao and Darshan Ghadge. We are guided by Professor S.S. Dongre sir and Professor Smita Shinde ma'am. So basically our problem statement is to design a cost-effective weather station for monitoring environmental condition, that is nothing but weather in real time. There are several weather stations available in the market, but the problem with that weather stations are they are very costlier. Their price is very high. Here are some examples. You can see the ambient weather model name VS2902. It is having price 18,900, and the second one is having cost of 52,400. So this is the basic block diagram of our project, where you can see we are collecting data from 3 different sensors: DST11, MQ135 and LDR. We are getting the data, we are collecting this data by Arduino, and this data is displayed using the display LCD, and this data is sent to the IoT cloud by using Wi-Fi module. So starting from the first sensor, this is DST11 sensor, which reads the temperature value and humidity value. Actually it has 3 pins, one for VCC, one for ground and one for data. It uses single serial communication protocol for sending the data. So it actually sends the data in 40 bits, that means 5 bits. First two bytes are contain the value of temperature, the decimal part and the fractional part, the integer part and the decimal part. and after that there are 2 bytes of humidity, and after that there is a 1 byte reserved for the sensor response, which sends response to the microcontroller. And after that there is a sensor called MQ135 which senses the air quality. Actually it gives output, analog output. We can observe that by multimeter. Here we had done the we had used mapping function. I can show you to here we are getting the values of MQ135 and stored it in the one variable called air, and then I map it to value from 100 to 0, nothing but in percentage. I have scaled down it to percentage. Otherwise it gives reading from 0 to 1023. So the next sensor, nothing but the component we had used in our project, is LDR, which means light dependent resistor. It changes its resistance when the intensity of light fall on that LDR changes. Basically the working principle of MQ135 is, I forgot to tell you that it has a material which has the property of chemi-resistance. Nothing but it uses tin dioxide when there is a clean air, nothing but oxygen. Oxygen is present in the air. The heating element is heated by the power supply of 5 volt, and then when the it gets contacted by when it so the sensor MQ135, it senses the harmful gases or the contaminated gases present in the air upon some fixed volume. Here we can consider it as 1 meter cube of volume. Then after we collect the data by using microcontroller called Arduino Uno R3. We have used Arduino Uno R3 for collecting the sensor data, and then we send that data to the Wi-Fi module by using the protocol called UART, which uses the two pins for communication with the another board. Here you can see the transmitter pin of the Arduino sends data to the receiver, and the receiver pin of the Wi-Fi module receives that data. Actually, I had done the program which sends the data in this format. The first value is temperature, and then humidity, and then the air. I think it is actually we can export this data to the CSV file. I can show you in brief. Here comes the option for that. Export recent data. I am exporting temperature data to CSV file. I click on that, then the one file is downloaded. I open it. Here you can see the recent data. So the future scope of our project is we can send this data via GSM technology to the farmers using SMS. Also we can add more sensors to our prototype for increasing its reliability and functionality. We can increase the optimal range by using more precise and reliable sensors. Here are some future scopes of our project, and this is the report of our project. You can see here. I can show you the budget. Actually, these are the different sensors we had used. This is the budget actually without IoT. I have added one more sensor for that Wi-Fi module, and the total cost of our project is from 1600 to 1800 only, and that's all. That's all from our side. Thank you guys.